the triangle segments portfolio. All right, and so it will walk you through the process here. So question 1 talks about on a blank sheet of paper, we are going to sketch a triangle, and that's exactly what I've done here. I've got G, I've got H, and I've got I, and I just drew a coordinate plane on a notebook paper, and that's perfect. Okay, it doesn't have to be anything fancy. You don't need graph paper. Okay. So what we're doing here is we are going to then sketch JK, and that's what I've done right here. So JK is parallel to GH, if you've drawn it correctly. So that point J is on GI right here, and point K is on HI. So HI is right here. Your triangle doesn't have to look like this. Okay, but I find that it's easier just to make it a right triangle and align your values G, H, I as a right triangle on the axes. Okay, but again, you don't have to do it this way. It's just an example. Okay. All right, B says prove using a 2-column proof or a paragraph proof that GJ, so G to J, is proportional to J to I. So J to I, and that HK right here is proportional to KI. Okay, and so what I did was I just wrote out a 2-column proof. Okay, and talked about that process. So where did I get most of this information? From the actual lesson. So I just copied down a lot of the stuff from the actual lesson with regards to my 2-column proof. And I don't care if it's a paragraph proof or 2-column proof, either one is fine with me. So I just walked my information from the actual lesson. Okay, so I've got some corresponding angles. I can use angle to prove that the 2 triangles are similar, and then I can then prove that they are similar because of the triangle proportionality theorem. So that's the whole objective here. With the proof, and I apologize for the scribbles. I did it in pen and made a mistake here. So, and then part C says explain how your proof in part 1B demonstrates that JK divides 2 sides of GHI proportionally. And then I just kind of gave a short description here. So I talked about how, let's see here. So because both triangles are proportional, JK divides the original triangle GHI by a scale factor of 3/4, 3 to 4, and so JKI is 3/4 the size of GHI. Okay. Now, you don't have to talk about the scale factor, but I did just because it makes sense with regards to proportionality. Okay, but you don't have to do that. Okay, so again, let's review real quick. We needed to draw the triangles in a coordinate plane, and then we needed to give a proof, 2-column proof or a paragraph proof. Again, I got most of this information straight from the lesson, and then I gave a description of why at the very end that JK divides 2 sides of GHI proportionally, and I talked about the scale factor. Okay. All right. Let's move on to question 2. So question 2, there's a little bit more direction with question 2. So let me go ahead and start with my graph. Okay. So question 2, it says on a coordinate plane on graph paper or just regular paper, it says to create LMN, where LN is a vertical line. Okay. So in this case, we have to have LN as a vertical line, so it needs to be vertical, and that NM needs to be a horizontal line, so it must be in this configuration. Now you can move it up and down or left and right, but it has to be vertical and it has to be horizontal. Okay. Then it says where LN is a vertical line, it says create QR. So QR is parallel to LM, okay? So QR is parallel to LM. So if you want to, sketch this out while you're watching it, you certainly can. Okay, it says that point Q is on LN. So this is LN right here. So Q is on that. And then R is on NM. Okay, so again, the configuration of this one is a lot more specific. Okay, and then from here for part C, you want to label the coordinates for LM, N, Q, and R. So I labeled those coordinates. We're going to use those coordinates to then find the slope and the distance. Okay. So the first thing I did for part D then is to find the slope. So to find the slope of LM and then to find the slope of QR. So I want to compare those. So from L to M, this slope here, and then from Q to R, so I want to find this slope here. And I was very intentional and very clear about which one. This is LM, this is QR, and notice that these two slopes are the same. So they're both -1, which is what they should be. They should match up. They don't necessarily have to be -1. It could be whatever slopes you used, but they should be the same. All right. And then for part E, then the next thing to do is to compare the distances. So I want to compare LQ to QN. So LQ to QN. I want to see the proportional relationship between these two. So I found the distance of LQ. Now, do you have to use a distance formula? I probably didn't have to. I could look at the graph and see that these are 1 apart, but I use distance formula to show that. So let me move this up so you can see it. Okay, so I use the distance formula here to find that LQ is 1, and I use the distance formula here to find that QN is 5, so it's a 1 to 5 relationship. And then I did the same thing over here. So to find MR, so MR is also 1, and RN is 5. So again, it's a 1 to 5 relationship, which means that they are similar. Okay. And so I used distance formula to show that they are equal to each other, which they are, 1 to 5 and 1 to 5. And then F says explain how your calculations help confirm. Okay, well, I've proven that LM and QR are parallel. Then we can use that to prove that the mid-segment is proportional using the distance formula. So I've taken the information about the slope and the information about the distance formula to make that connection. Okay, so it's a nice way to kind of summarize the calculations that we've done here. Okay, so for F, again, you're just calculating, you're just using that information to prove that those two segments are indeed parallel to each other. Okay, so that is part 1. Part 1. So now we need to talk about part 2. So part 2, let's take a look here. So part 2, I think it's due today. So hopefully this helps a little bit. And they talk about some different strategies here with the mid-segment theorem. Then they give us some really good proofs that I found to be very useful. And then they talk about the converse. Okay, so let's go. And here it is. Okay. Art. All right. So question 1. And I had to cross out the top section here. So let me move this down so you can see it better. All right.